Okay, let's begin by factoring this equation. The top can factor out a 3, and the denominator, that factors to two binomials. We need two numbers that multiply to make 21 that add up to positive 10. So that's going to be 7 and 3. Now because there's an x plus 3 on top and x plus 3 on bottom, that actually identifies for us that there is a hole at the opposite of 3, negative 3. And furthermore, that means there's a vertical asymptote at the opposite of that, so that's where your vertical asymptote is going to come from. That's going to be negative 7. The horizontal asymptote would come from looking at the graph, but it turns out on this one that it's going to be y equals 0. Again, you'd probably, if you had a graphing calculator, you'd be able to see it. So what I'm going to do is I'm going to count to the left, 1, 2, 3, 4, 5, 6, negative 7. That's going to be my vertical asymptote. And like I said, just from looking at, using technology to graph that, it turns out there's the asymptote going across here too. And so the function, I believe, just looks like this. Sorry. Don't like that. That was a bad job. Try to get my graph closer to the asymptotes here. There you go. And I believe it does something like this. Alright, there should be a hole at x equals negative 3, which it means there's a hole in the graph right there, and we're done there. Moving on to some multiplying and dividing problems. So I am going to factor every part that I can. Now I can't do much with the 6 or the 10x squared at the moment, but on the top of that I can factor out a 2x, and that gives me x plus 2. In the denominator I can factor out a 4, and that's going to leave an x plus 2 down there. Now I can try to reduce some things. Easy to see that those cancel out. A lot going on with those numbers. Let me just sort of take a moment to just kind of multiply and squish everything together from left to right. So what I'm doing here is looking at 2x times 6 is going to be a, let's see, 12x squared. Furthermore, I've got a 4 times a 10. That's going to be 40x squared, and I just realized that's not supposed to be squared, sorry. 2x times 6 is 12x. Alright, here we go. So furthermore, it turns out 12 and 40 can reduce. Let's see, 4 goes into 12 3 times, and 4 goes into 40 10 times, so 3/10. And then this x and this x squared cancel out. It just gives me a single x on the bottom. That's the final answer. Let's see, letter B. I'll switch colors here. Letter B, let's see, I can't do anything with the top of that at the moment. Actually, I just changed my mind. This one's already factored, so I'm ready to start canceling right now. This little x plus 7 and this x plus 7 completely cancel out. Let's see, I can sort of do a little bit of this little 5 goes into 5 one time, and it goes into 15 3 times. And furthermore, since you got the x squared and the regular x, so one of those x's cancels out, and I believe that leaves me with nothing but a 3 on top and an x and an x plus 3 down below. And that's as simple as I can make it. Letter C, remember that we need to do a little, so we keep the first one the same for the moment. I change the division to times, and then I flip the second fraction over. Now I can do a little bit of factoring. The top of that can factor to be this. Alright, so A little simplifying here, that x plus 2 and x plus 2 can cancel out. This x cancels out with this little square that leaves a single x on top. Let's see, 4 goes into 4 one time and into 16 4 times. So it looks like all I've got on top is a 3 times a 4, which is a 12, and an x. And that's my final answer because there's nothing left on the bottom. So that's it. Alright, solve these ACT problems. Alright, which one of the following is a solution to that function? Now the simplest way I've got would be to just take these answer choices one at a time and plug them into the x's here and here until I get a true statement. I think the way the problem was intended, though, is that they expect us to get this thing set equal to 0 by minusing 6x from both sides. That would give us this, x squared minus 6x minus 16, and that's now equal to 0. Now that looks pretty normal from what we've seen in class many times. And it turns out that I believe that that thing is going to factor, yes. Two numbers that multiply to make 16, negative 16, add negative 6. I feel like that's negative 8 and positive 2. Therefore, one of the solutions is positive 8, and one of the solutions is negative 2. So, the only one of those I have is number 8. There we go. Number 4, for what value of x is that equation true? That's, in other words, it just says solve. I mean, that's really all that means. Sorry. 2 times x and 2 times negative 6, a little distributive property. And combining like terms, 2x and x makes 3x. Add 12 to both sides. That gives me 3x equals 48. Divide both sides by 3, or in other words, just 48 divided by 3, and I get 16. So, there we go. Is that it? Oh, we're all done. That's too bad. There you go.